And can you make me a host?
Unexpected.
Yeah. We're doing this to check who's really paying attention.
Yes, yes.
That's the technique.
Oh, I have to rejoin.
Yeah. Yeah. Thank you. Sorry about that.
Maybe the next one we can do in virtual reality environment.
Yeah.
Are you the co-host? Are you a co-host?
No, I'm not.
Because I can't go in. Can you make? Sorry, so we need to be letting people in.
Actually, Katie Douglas is the co-host. So
We just make a few more people co-host.
Hi, sorry, I don't really know what's going on here, but how do I give this power back to you?
We are figuring it out.
Was that a computer-generated voice?
Yes, widerrufen. Genehmigung. No.
No?
No. Wait, should I hit it?
Yeah, yeah.
So,
Okay, and you?
this. This.
Set the meeting to end at 7 p.m. So
Maybe in the meantime we can ask some questions.
yeah.
Yeah. So Jared, I was wondering, I think it's really cool. It's also it's a lot, right?
Yeah, it's a bit overwhelming.
But yeah, in a good way. But I wonder, so this is going to be part of our lives. It's even the creative process of thinking about avocado chairs is something that we in the future might first do with a machine and then pick out, and that's our creativity left for the human condition, and then something, right?
Yeah.
But what do you think that we as what kind of techniques should we become familiar with, or at least knowing a basic understanding, because this is gonna be part of the science, it's gonna be part of our lives even. Is there one particular technique which you think we should become familiar with or understand conceptually or even technically? As cognitive scientists, for example, specifically.
No, as cognitive scientists, I mean, it definitely helps to know some basics of machine learning, especially some of the issues of data. How do you represent data? How can bias in your data affect the outcomes? What is a system really doing when it's making certain predictions, not to blindly trust whatever comes out of the system. I'm hoping that there will be advances in explainable AI, that basically any system that does something that really affects our lives also is able to basically be traceable and has some accountability, and we can go ahead and see what exactly the model was doing and see if it really makes sense or not. Right now, that is still sometimes limited, but there's all this legislation appearing, and so there's a huge need, and probably we will see better and better results there. Some people might say, okay, everyone needs to become an AI expert now, or everyone needs to go ahead and study computer science and learn how to code. And I wouldn't go that far. I mean, definitely there is a need to, we definitely need more people who have such skills. There's a shortage of labor in many of these sectors, but I wouldn't necessarily say everyone needs to know how to code. Rather, my opinion is that anything that's really important is going to find its way into easy to use tools and apps. And so I was presenting these style transfer examples where you take an image and turn it into an artwork using another image for the style. And that now exists as a mobile app that anyone can download and just use. And so similar things are happening for other developments in AI. So I think the important parts of AI will just be easy to use. People are now developing AI models that help you develop software, that auto-complete your code, where you just basically write a sentence and it generates the whole function, or at least attempts to. And so Maximilian Schall above there, he's working on like related technology to automate some of the coding process. So basically, it's hard to say what specific technique you should know. Rather, I'd say you should have a basic understanding of when to trust a system, what they're doing at an abstract level, so that biases don't affect your results, or that you can just make sure that it's reasonable what the system is doing and not just blindly trust it. And also these aspects that if your data just had all of these, like this comes up now in job applications, people using AI to review CVs. If up to date you were mostly hiring men for certain roles, then the AI system might learn that and then prefer, even just in subtle ways, give preference to people who match that profile. And so these risks need to be known, that the system is just doing whatever it's seeing in the data, and the data might be biased and the models have certain assumptions. So these more abstract questions, I think, are important.
I would have a question, because I more hope that maybe you still have things that got in your slides. So I've always, I mean, in my interaction with your group and some of my interaction with the cognitive science guys, are there things like gesture stemming that you've seen? So because we have image process, we apply some processes to images, or apply some processes to text, but we have pronouns and verbs for text. We have images, labels, or cats. But once we come into the gesture environment, it is a mixture of everything. Oh, yeah. So I took the liberty to record you a bit during your session, and I was trying to pay attention to the words you use consistently and the gestures you are using, if there was any consistency there. So, but I'm not sure do we have pronouns for gestures where we could say we tokenize them, we stem them? Do we have gesture transformers? Is that the state that we could get to? And it's more of an open question for the bootcamp, because then maybe we have gesture language processing and becomes more of a more robust field where we can leverage what has happened in text and image there.
Yeah, definitely a promising avenue. I think other people here would know more about that than me. So some people here are experts. Yeah, so I haven't done that much work on this, but there's definitely potential to just treat it as a sort of stream of inputs and then look for patterns in the gesture. Of course, gesture is not quite like just words where you can have these discrete labels for them. But you could, I mean, I showed some examples of where we can just take phenomena that are not quite discrete, but still view them as discrete. So you could use some of the same techniques. And since we're usually using vector representations, we can also deal with things that are not quite discrete, where people might use a gesture in a mild way or in very excessive way and still capture those differences.
I noticed, sorry, you said that you were talking to the group, so I took you literally. I don't have a name to give you, but I know that in Frankfurt Oder, there are people doing work on gesture and politics and analyzing the gestures that politicians use. And I think that is incredibly interesting, and also looking at our political climate, really important, because yeah, it has a huge influence. And since gesture, we are a bit of an exception, but for most people it is very much under the radar. And so knowing what is happening, I think is crucial.
Yeah, I think the participants also sign in when people are looking at gestures in mathematics, what teachers use to make sure that understanding is increased and all that. So yeah, I see opportunities where we can really look at all those microdynamics where we better in that sense, without too much labeling, because asking teachers again to label videos, they just want to teach. Yeah, cool.
We started teaching, Joaquin and Baba and I, teaching people gestures on Teams. Specific types of gestures for categories or levels of what they were going to be talking about. So if it was touch points, it was like this. If it was functions or scenarios, was like this. If it was networks, like this. It was a core functionality, something that was like this. And we would drill them because it's anecdotal, but it seemed to work because people were getting cued into, oh, we're talking about networks now. And everybody understood that now we're talking about networks and nodes. Or let's talk about touch points. So it's a button, right? And so we actually taught these people to do this stuff, and we had all these exercises to do it. And it seemed to increase communication, cohesion, being on similar pages. But it was only anecdotal. We didn't do a formal study of it. But it opened, I think its biggest effect that we noticed, it has opened up people to the distinct notion that your gestural communication is extremely important to the success of your team, right? So it was opening their awareness to it. But, and we picked those because we saw people doing that, right? We saw people doing this when they were talking about buttons and that kind of thing. We saw people doing this when we're talking about scenarios, right? So
yeah, you could continue your talk. Thanks for letting us ask.
Right, yeah, sorry for the technical issues we had. We were filling this gap with a few questions, and this led to an interesting discussion about gesture. So I was just mentioning that basically we're generating more and more of these virtual environments, and there people have been creating data sets where you give instructions to the system just in natural language and human language, and the system needs to follow these instructions. And so the nice thing is the robot, the virtual robot, then in this case can try out these things without causing any damage. So it's a much safer way to run these experiments, and you can easily repeat these experiments thousands of times and try out different things. And so there's also a general trend nowadays towards digital twins and simulating different kinds of phenomena virtually, so that basically we can scale up our simulations and do not need to run any costly kinds of dangerous, perhaps, experiments in the real world. Okay, so I think this was already this first part. No, I still have more. So this was the first part, and I still have a last part then, which brings us to NLP. I mean, I could also do it in some other session, but we do still have some time. So this was mostly now all about computer vision. I know it's been a long day, but now I have a final part that is talking a bit about what are the developments in natural language processing, which is also something that I'm very interested in because my background is mostly in this area. For a while, I was also very deep into linguistics. I was in a team that was consisting mostly of linguists and cognitive scientists also for some time. And so some of the techniques that apply to computer vision also apply to NLP nowadays, but the traditional way of doing NLP was very different. You start out with your text, and then you have a whole pipeline of different processing steps, usually very basic ones like tokenization. What are the words? And that's not always easy because like even here, if there's a comma, a new word starts, but certain symbols don't start a new word. And then, so tokenization is the first step, split a text into words. Then there's stemming, like finding out the basic lemma form of a verb, going from had to have. There are things like normalizing for case or different variations of writing things. Sometimes we also do things like removing all the non-content words if you just want to get the gist of what a topic is, what the text is about at a topical level. And then there are some steps you can do on top of all of these pre-processing steps. There are tasks like part of speech tagging where you just label every word with the grammatical category. And so this can then be used already to do various kinds of analyses of your transcripts or texts, like what are the most commonly used verbs that people are talking about or using, and what kinds of adjectives are they using, and nouns or specific categories of nouns, like what kinds of locations are they talking about. So with these sorts of simple tagging techniques, you can do quite a bit already. Important for us in this setting is also co-reference resolution. So if you have a pronoun such as he or her, she, and so on, the system should be able to resolve this and figure out who the referent is, because we don't always repeat the full name, of course. So this is something that the system then needs to guess based on various kinds of clues, like how close, who was mentioned before that, and how close were they mentioned. And the system also needs to make certain assumptions about gender. In some cases, otherwise it might make false predictions. And then other steps include syntactic parsing, figuring out the grammatical structure of a sentence. And there are different formalisms that people use, but some that have become popular in NLP. So these are some of the traditional ways of doing natural language processing, all these individual steps, separate tasks that mirror the kinds of things that people do when they study languages or do linguistics. Going beyond that, there've been some other kinds of studies that try to get at the actual scene that is being represented in the text. So basically the who did what to whom. So if you look at these sentences here, they're quite different. At least to a computer, they look very different. They start off with different words and using different verbs and so on. But to a human, it's obvious they're referring to a similar kind of basic phenomenon, basic activity. And so the idea is, can we automatically infer that this is some sort of commercial transfer and that the buyer in each of these sentences is John, the seller is Anna, or in some cases the seller might not be mentioned, and the product is the car. So this sort of representation is, I'm just showing a brief excerpt here, but this was done for many years in the FrameNet project at Berkeley, where they were labeling huge amounts of text and coming up with a very large inventory of these frames, and all the frames are organized in a network. So if I have a very specific frame, I can know what other frames it relates to and might be implied by this more specific frame. And so another team now in Brazil, they are extending this to multimodal analytics. So whatever we describe in language can also be applied to describing videos. And so they're labeling text and videos and images with these sorts of underlying semantic frames. And the nice thing is it's a consistent inventory, and many of the most basic frames, they come actually from cognitive science. So they're trying to organize these frames in a way that relates to some results in cognitive science. All right, so we also, as I mentioned, did some kinds of work that were a little bit inspired by these sorts of frames. I also did some other research that was more specifically related to frames. But as I mentioned, in many of these systems, we have a whole pipeline of steps. So first we do the pre-processing, then we plug it into another tool, then we do some other inference. And so a basic trend now in NLP has been to no longer have these pipelines where you first split up the text into words and then do the next step and the next step. You just have one big deep neural network, and you give it your input, you tell it what you want as the output, and the model needs to figure out on its own that there are, in some cases, even needs to figure out on its own where words end and a new word starts, or where, which language it is in and how this language works, what the morphology of this language is like. Everything is just left open, and the model figures things out on its own. So the most well-known example might be machine translation. It used to be very hard to create a machine translation system. Basically, Google had one of the best ones, and no one could compete with Google because they had resources, data, they had spent years optimizing it. And nowadays, basically, anyone can train a model that is better than that old Google system. And it's just a deep neural network that takes the input, it's trained to produce the output. It figures all the steps out on its own. It figures out, like, we don't tell it that there are verbs, there are nouns, that there are different forms of a verb. It's all just what's called end-to-end learning. The model tries to figure things out on its own. There have been different kinds of deep neural networks for this. Some of the first were more sequential. So every step goes sequentially, and the model kind of updates its representation every time it gets a new input word. And that sort of mirrors also the way humans process text, although it's not always linear. There can be return, there can be different kinds of back and forth if you do eye tracking. But in general, we also read text and hear text sequentially. But the thing is that now in the big data centers, we have these huge compute clusters. And so Google has their TPUs, and basically it is wasteful to do one step at a time. And so people came up with new models, the transformer I mentioned, where you can take the whole text and process every word at the same time. And gradually you somehow incorporate the sequential nature by having, by peeking at the other words. So any word can look at any other word and see what's going on there. And that is called self-attention. Basically, every part of the input pays attention to every other part of the input. And there's also cross-attention, that the input, the output pays attention to the input and the previous output. So you can see this is a very complex model, but, and this is even a very simplified view because it gets even more complicated. But at a very high level, it's basically just taking the input, it's refining its encoding of the input, and then you have a decoder that takes this representation and turns it into an output. So that's what's going on here. It's a network that is basically taking an input sequence and producing an output sequence. And one example of such a model, recent one, is this Google T5 model. And we can train this even without having training data by artificially generating some tasks. So we take a sentence that we just find anywhere on the web, we blank out some of the words and now, or some phrases, and now the computer needs to figure out that when it sees this sentence with the missing parts, then it needs to guess which kinds of missing parts might fit into that, into those slots. And so by just repeatedly training on this task, the model gradually gains an understanding of how language works, which words come after which other words, how does the grammar roughly work, that at certain positions you need a verb, at other positions you need an adjective, and sometimes you need to deal with all the grammatical inflections and so on. And it also needs to make sense of the content, because like when you're talking about a party, thank you for, then probably last week is more probable than next week. Usually when you thank someone, it was about a past invitation. So it needs to learn all sorts of things about the content, the real world, and gradually gets better and better at this. The T5 model, in fact, is not only trained on this, it's also trained on other tasks, like you give it a long text and it needs to summarize the text, or you give it a sentence like the course is jumping well, and it needs to say that is not acceptable in English to say the course is jumping well. So you can add additional label data that you have into the model, but the basic task is just not based on label data. It's just this artificial label data where you don't need a human to go ahead and create such training examples. You just take any sentence and blank out random parts of it. And so that's what allows us to scale up this training to huge amounts of data. And probably the most well-known version is called BERT. Some of you might have heard of it. It's also doing this sort of filling in the blanks. You take a sentence, mask a few words in it, and BERT just tries to predict these individual missing words. So what we found was that this very basic task, which is called language modeling, is quite fundamentally useful. So I used to kind of dislike the name language model, because what these models do is they're basically just auto-completion models. You give it a few words and it predicts the probability of the next word. And with this, you can predict that, well, where are we going is more probable than where are we zookeeping or some completely random sentence. It's all just probabilities, and the traditional models were just simple counting statistics. You just count how often you see certain phrases in language. And so that's why I dislike this term, because they were doing something very simple, and language is much more rich and complex than just counting probabilities of different phrases. But it turns out that these models are not just useful for auto-completion, as shown here. They can be used for various other things like speech recognition. Some of you might have heard these videos where they make fun of how you might mishear song lyrics. Like, I'm gonna take my horse to the hotel room. So a model can tell you which kinds of phrases are more probable, and you can just put that into a speech recognition system so that it prefers things that also make sense in human language as opposed to random combinations. Yeah, the actual lyrics would be Old Town Road, not Hotel Room. Another application is optical character recognition. Like you have the system needs to guess the words, and basically there might be different alternatives. And so we can just ask a language model which one is more probable. And that's a basic application. And then there are also things like some of you might know this movie series, My Big Fat Greek Wedding. And so adjective ordering in English, like you can't really say my fat Greek big wedding. Adjectives need to be ordered in a certain way, but it's very hard to describe, to figure out in which way they need to be ordered. It just comes naturally to native speakers. There are people who have analyzed this, of course, but for a system to figure this out automatically, it's not that easy unless you just train it on huge amounts of data and it learns from what it has seen. So with these older language models, you could do some of these simple tasks, but then people started feeding in this sort of task with into deep neural networks, and we could then observe that language modeling is capturing more of language than we thought. We thought it's just like auto-completing a few words, but what came out was mostly kind of random, just anything that you, like sequences of words that you would say. But then once we fed this into deep neural networks, it would start generating actual, I mean, not super sensible, but somewhat okay looking Shakespearean text. At least it's not completely off. It doesn't make much sense, but it's still, it looks kind of okay, like if you don't pay close attention. And so, and similar things happened then with Wikipedia. And so this was, I mean, it's still quite nonsensical, but it was much better than what we would get before. Before it would just be random sequences of words that fit together. And then suddenly it started producing these coherent long passages. And you could do the same even for source code, generate code that doesn't really make sense but looks kind of realistic, and it gets the indentation right, it remembers when to close certain blocks. So these are things that weren't that obvious that a model could learn.
Anybody try to run that?
Yeah, people first tried to compile it, and it would fail because there were small mistakes, but at least you could gradually get it to compile, but I don't think it would produce something meaningful. So this was like around 2014, 15. But now in recent years, these models have become even better. So they've been fed into, we've been using transformers, and these have been scaled up to extreme levels. And so now I can write something like recycling is good for the world, and then I start a response, no, you could not be more wrong, in capital letters. And so the model figures out what would make sense as an auto-completion and writes this whole long essay on why recycling is bad. And it's emulating the things it has seen on websites such as Reddit and other kinds of
Pollination.
So the difference is now that even semantically, it is kind of reasonable. It's not always perfect. Sometimes it still gets things completely wrong, but you can actually use it to come up with arguments for certain positions, to extend certain kinds of texts. There are online tools where you can say, okay, one of the best musical artists of our time is, and then you get an actual meaningful essay. So nowadays, I wouldn't want to be a school teacher who has to grade student essays, because you never know how they came up with their essay text. So a lot of it is reasonable, and some of it might be made up. I don't think she really has an album called Symphonic Lover, for example. There are also, of course, ethical concerns. There's this whole well-known paper that got a bunch of Google researchers fired ultimately when they wrote it, where they were criticizing these language models. Some of the criticism is about biases, stereotypes. So you can get these models to generate racist statements, for example, and deploying these models then becomes a challenge because on the one hand, they're so good at language. On the other hand, if you create a chatbot and this chatbot now says something offensive, then you're in big trouble. And so we don't have a good solution for this. I mean, people build in swear word filters, of course, they build in certain hate speech detection, extra modules, but still ultimately it's hard because something offensive might be worded in a way that slips through these detection algorithms.
Can you bait them?
What was that?
Can you bait them? I mean,
Bait?
is it, you know, it's like, you can bait them to like say awful things. Is there a way of doing that if you understand?
Oh, well, you can definitely train a model to say awful things. That's very easy.
No, I mean,
But
as a user.
to not say awful things is hard because it can slip in, it can, and when, even if you just train it on novels, you'll get offensive things. So there are very few sources of clean text. And even in that clean text, certain things might come out
I can
just
only
by
imagine
mistake.
nuances or whatnot, but I'm wondering as a user, a way to mess with the system, like are there techniques to get the system to say something
Oh, yeah.
inappropriate?
Oh, that happened already. Like Microsoft released their Tay chatbot, and then that was a big scandal when people just provoked the chatbot to say very racist things.
I'm sorry, that's awful. I mean, that's terrible. I mean, I'm laughing about the whole idea.
Yeah.
Well, people are messing with it just to show you that they can do that, but it's just awful.
Right. So that raises then a lot of concerns about how can we actually use these models in production. So still a lot of companies are just have a like small list of hand-coded things that the model can say, and it needs to pick from those, and
Okay.
it can't really just say anything it would normally want to say. So that's the only way that's truly safe so far. Another concern is also that these models, the CO2 consumption, or like this whole idea of green IT, that's a big issue. Some of these models are using huge amounts of resources. They've been compared also to plane flights and so on. So they can take on quite large numbers. But on the other hand, what is also true is that there's a lot of reuse. So one big model gets trained, and then if it gets shared, it can be used by people all over the world for many different tasks. So you train it once, and then it has these different capabilities for many different tasks. And so it can be used quite flexibly. And the common way that happens is by pre-training and then fine-tuning it on a new task. So you have the existing model that already has a basic understanding of language, and then you specialize it to do a specific task, such as sentiment analysis. So you add some label data for your specific task. Now, in recent, just the last few years, it has been more and more popular to have models that are so powerful that you no longer need to label examples beforehand. You just feed in something like this was my first visit at Sun Kitchen. There was a queue, but the food was delicious. And then you just add it was, and now you predict good or bad, which one has a higher probability. And so a language model can now do sentiment analysis just by predicting which of these two labels is more probable. Or here's an example of a language model, and you can see nowadays there are good libraries that allow you to do this with just 3 lines of code, basically. can do zero-shot emotion classification. So I feed in, suddenly a huge black bear appeared. I feed in a bunch of candidate labels. It didn't train on these labels specifically, but it tells me for each label what the score is. And so you can then automatically predict which labels are most appropriate. Or you can automatically do summarization, like the model wasn't trained to summarize, but you just add as a prompt summary, and now the model generates a summary of your input text. And so this is all called zero-shot learning. You don't train the model specifically, you just reuse the language model for this task. And so this is showing that language modeling can be quite universal. It can even do machine translation nowadays, since it's trained on all sorts of text from the web. You just say translate English to French, cheese, and then you add this sort of arrow. And you might also do one-shot learning where you at least give it one example of what you're looking for, or a bunch of examples. Then it's called few-shot learning. The more examples you give it, the better it's going to work. But it's still much better than before, where typically to train a model, you needed a couple of hundred or 1,000 examples even. And well, beyond this, there are people using these models like to automatically generate database queries in the SQL query language. So maybe in the future, you don't need to be an expert of SQL. You can just have the system translate your English query into a database query. There are people using it to translate legalese into more understandable English, and this is all without extra training. So you just give a bunch of examples, well, like one example basically, and then along with a description, and then the white parts are what the, no, the white part is the, I don't know, either way, the system then generates, I think these are translations now into legalese, probably. Yeah. And then here, this is also a system doing some coding, helping with a coding interview. And so in this case, the human, whatever coding interview questions during the job interview, the human is getting, it's just having the AI system answer them. And not sure if this example is really true. This was from social media, but seems to work quite well. And there are some systems that are doing this now really well. All right, and then the final part is, I'll skip some of these slides because we're out of time, but there's more and more speech recognition. There are dialogue agents, like Barbie with the speech engine. You can use transformers now also for speech, for customer chatbots, customer service chatbots. And so there are all these problems dealing with dialogue, that you have different people speaking, different people taking turns. And so we're also doing some research on this, how to keep track of who is who, what personalities they have, what we know about each person, and make the model properly deal with this. There are disfluencies and things like and you've all seen this in transcripts. So there are all sorts of challenges, but a lot of advances nowadays. So hotel booking services and ways where we can analyze at a more abstract level, inspired by speech act theory. We can then automatically figure out that if someone says, "Are you joining us for lunch? I've got to finish this report." For the computer, it's not obvious that this is a no, but but gradually systems are getting better and better at this by with some labeling and dealing with these sorts of things. So internally, we have some intent recognition and have the system then generate some internal representation of what is going on. And then, like here's another example, set an alarm. And so the computer needs to learn how to go from the input to this internal representation of what is going on. And traditionally, we used to define rules for every, like how something might be phrased and what the corresponding intent is. But nowadays we have increasingly deep neural networks help with this part and automatically do the mapping, even if the human then writes something in a different way than we pre-specified. Okay, so I'll skip some of these internal details. It's all kind of deep learning for generation can be used, or templates, but there are many challenges like uncertainty, words you didn't recognize in the speech recognition system, or corrections if someone says, well, actually, I would consider saying they're an extra day. And so these things still confuse dialogue agents, because first you say one thing and then you correct yourself. And then what does an extra day mean? Like figuring out that that is 1 day later than what you had previously said is not so easy. Okay, and so then the trends are more and more personal assistant, dialogue bots everywhere, these videos where you have someone just look at their watch and say something like, what is the length of this river? So the local context, GPS context is taken into account, and the system can know everything about you, about your habits and where you are, and take all of this into account. TVs, cars have these dialogue assistants, and the last step is then, can we get to true AI? Some of you have seen this imitation game. And in AI, we have, so the Turing test is basically the system needs to guess which one is a human. There's a human and a computer it's chatting with, and the system tries to impersonate a human. But there have already been long ago systems that kind of found some loopholes, like this one system that pretended to be a person with paranoid schizophrenia. So saying things like, it bothers me just to be around people in general. So always reacting with some very negative, defensive kinds of statements. And so this system was, at least according to one study, was able to fool. So the psychiatrists were unable to distinguish whether it was a real transcript or of a human or of the system. And also recently this bot fooled people by pretending it's a 13-year-old boy from Ukraine, who of course then misunderstands things and makes spelling mistakes. So people were more forgiving and more willing to believe that the system is not behaving the way you would expect a more competent speaker to respond. So people are kind of moving away from the Turing test as a good test for intelligence. We're just looking at what can these systems do? Can they achieve the things we want them to achieve? And so people are using like these transformer models to automatically generate emails. You just say, I appreciate the team for their amazing product, and it generates a suggestion of a whole email that's really polite and kind. And so, and then people are using AI to automatically generate a video in 1 hour instead of days. So creative tasks as well. And some of these language models now can also pretend or imagine. They're not really imagining, but they can autocomplete something in the style of a certain person, celebrity, like how would Richard Dawkins describe the central idea of the selfish gene? And so even autocompletes the best wishes Richard at the end. So these models, just by doing language modeling, they can do quite a bit. And this one person wrote a whole book in 24 hours with the help of this model and got it published, of course, also as a kind of marketing trick to have the system as a co-author, although it's not really a conscious co-author. But definitely these systems are becoming more and more useful. Okay, so the vision is to have all these different kinds of data feed into single systems, and that way they learn more than they would just from language or just from single images. They're learning from video, they're learning from text, they're learning the connections between the different modalities, and maybe they're learning from simulations, and we also feed in any labeled data we do have, so we can correct certain mistakes and get the system to like avoid hate speech and so on. And so with that, I'll end my talk here. Is this classic Alan Kay quote, "The best way to predict the future is to invent it." So in AI, we're always looking at like, what's the next big thing we can do with all these technologies, and what can it enable? All right, thank you.
Thank you, Professor Melo. Questions from the audience will be very much appreciated. We have about 20 minutes. Questions, comments, particular slide you want to see again. If you're interested in GPT-3 and how it can cause trouble in your research group. Yeah, questions online.
I have a question. So I think this is all really cool work. And yeah, my question relates a bit to kind of the first part of your talk where you alluded a bit to this this tendency for the complex models to be a bit like a black box where you don't know exactly how they work in the end, but then it's exciting if we can get them to work, to do these things. And I'm wondering basically what your idea is of what's important as a direction forward. Should we be trying to primarily generate models that are better and better at doing these different tasks to really just focus on making them really good at things and maybe even very flexible and kind of this way? Or should we be saying, actually, let's slow down on doing different stuff and being better at all these crazy, really complex tasks, and let's make them understandable in terms of their mechanisms and how they work, or something in between? Where is this kind of balance, do you think, in terms of what we should be kind of focusing on or really stressing in this type of research?
Right. There are people who are saying, well, we need to slow down. We don't even understand these models properly and how they're working. But I guess in general, the field is full of people who are just excited by all the things that are suddenly possible. So even no matter how many people are raising certain concerns, the big companies are also fighting for dominance. Even entire nations are fighting for dominance. So the European Union is funding some projects to have similar models for European trained in Europe and China. We're also in touch with some people from my former university. They're working with industry to train Chinese multimodal, big, huge GPT-like transformer models. So all of this is just happening because that's basically the incentive structure. It's people are kind of betting on AI having such a big impact that whoever is first will kind of dominate the market. And we have seen this. So basically, like when I started off, it was very rare for big companies to release something for free. Most of it was kind of secretive, and suddenly Google changed their attitude and released all these free libraries just so that everyone would start using them and use like TensorFlow instead of Facebook's PyTorch. And so they want to then encourage people to buy into one ecosystem and also be known for a certain product as the key player in that market. So there are all these incentive structures, and so definitely the people who are making the decisions have kind of decided, well, we're going to go ahead and train all these increasingly large models and just see how big we can make them, how much data, what else can go into them, even if there are certain concerns about like biases, even things like copyrights. So GitHub trained this model on all the source code they had available, and they didn't even exclude code that had certain license problems. So the auto-completion could sometimes produce code that actually was written by someone with a license that didn't allow redistribution, but it would basically transfer ideas it has learned from that code into whatever auto-completion you do. So sometimes these, even the big companies are not cautious at very basic levels. So yeah, it's very hard, and even national bodies in the European Union are funding now all these local models to be trained. Like there's a big effort in France and other efforts in Germany, like Gaia X and all of these things. So basically things are just progressing. But I would say for any particular task, you need to be very careful before you deploy it. Like certain very subtle biases might be affecting then all of your outcomes. Like I get requests from people who want to use models to automate judicial decisions, and I'm very skeptical about that. But they're just saying, well, the courts in Germany are so overloaded, they have such a huge backlog that any automation will just be a huge relief. And every time there's like a flight delay, there's this huge long document, like 60 pages long, that no one can read. And so we just need a system to help us speed up this process. So I would say hopefully we can design systems in a way that we can have more automation, but without these risks. So yeah, I'm thinking like there will be research that progresses at a fast speed, but also careful applications due to new legislation in the European Union that's coming up next year probably, and also phenomena like lawsuits related to that, or whenever we have a new model, we need to basically know what to expect from it. So sometimes also our expectations change. Like back in the days when we looked up something on Microsoft Encarta, it was an encyclopedic article and we knew it was kind of reliable. And nowadays we look up things on Wikipedia and we know anyone could have entered it, but we kind of learn to live with this. And the same thing happens with Google. Like we know that when we Google something, it could be some random website, and we just live with this inherent uncertainty and risk. So it'll be a mix of these different things. But yeah, I don't have good answers either.
Okay, thanks.
Any other questions, comments?
Someone, I think online had a question.
No, not yet.
No?
I'm monitoring.
Okay.
Yeah, Jared, I'm wondering if you could say a bit about how we could learn about the principle of accessibility. So Google, Facebook, I know it's the competition that forces them to try and make things accessible to society, and in that sense they get legitimacy, but how could we as a research community apply some of those principles so that, like, I mean, learning about teams, about how teachers teach mathematics in class can also enjoy those scale of insights, because not everything is about self-driving cars and yeah, but the real things that could matter to some small niches, how could we be inspired to try out this accessibility? I remember this app that allows you to change, you can tweak your face to be younger or older, you can see your older self, and it just went viral very, very fast. And then we said, oh, it's from Russia, it's from China, it's from here. But it's out there, it's gone. And somehow, as research communities, we don't have those tactics too. We don't, well, there's enough to battle with about the rigor and where am I going to publish, and then before you look at accessibility. And so that's one of the things we're trying to explore in the bootcamp, and maybe you could shed some light on that.
Yeah, that's a good point. So much has happened in industry, but elsewhere we still need better tools, better platforms is my answer. So once you enable some tool that people can use, that's when people start sharing and providing content. And so we need the right kinds of platforms. Like Wikipedia was this one platform, like anyone could just start writing articles about anything, even like Pokemon characters or uh, random sites, touristic attractions in your hometown. And so everyone started contributing. And we need more such platforms where people contribute to one shared resource instead of having these different silos. And it's not so clear what kinds of platforms it could be, but definitely in the tech world, we have been seeing this, like with GitHub. So much code is being shared nowadays that coding has totally changed. Like it used to be, you needed to like subscribe to some magazines, and sometimes they would print some interesting code and then you had to type it into your computer. And nowadays you can download any sort of interesting algorithm and just try it out and use these free resources. So in our world, a lot has changed, but we need more platforms in other worlds. Educational resources, for them, for those, there are certain like websites, there are lots of free resources available, lots of things being shared on YouTube. And so that sort of helps, but maybe we need better platforms where any teacher who develops some interesting new way to teach a concept can just upload it and others can reuse it. So we need more platforms for more kinds of communities. And sometimes these arise organically, but mostly they arise, I mean, you need someone with the tech background to create the platform. So they happen first in the tech world, and then you need someone who is in the tech world and in this other community to develop the tool for them. And so sometimes the right expertise is not yet there, and maybe someone just needs to gather some money or fund such activities to develop such platforms.
Thank you. Thank you very much. A round of applause. So yeah, taking down those keywords, it's a classic design move. You hear something, you change the first few words, and you say, what if we had gesture tokenization? I think it's already in your paper, but maybe you hid it in the appendix, or the reviewer asked you to remove it. But we're now saying, okay, what could gesture transformers look like? And what could, all these things that you already have in the different modes that exist. So text and images, what could that mean for gestures? And translating it might have its flaws, but it's a good start. And I'm hoping that we can facilitate that kind of bridging in the next 2 days and more. Thank you very much, Jared. It was really, really great. Nice. Big picture, but still with a lot of technical details that gets us really, it's like coffee. It will be like coffee for women.
Nice.
Thank you very much. So now I want to just wrap up with summarizing what happened today. So we had an introduction of what this event was about. If you're still online, you're still at the Envision Bootcamp. It's the first one. The Bootstrap Bootcamp. It's inspired by Jared. When I was going in the train with him yesterday, he said, we should think about this bootcamp more like a bootstrap. So I was like, I should write that down because that changes everything in that sense. So again, thank you for allowing us to extend the time till now. On behalf of all the hosts, we appreciate everyone, the technical crew. Thank you for making this happen. My sister, very dear sister, Lola, for sorting out food for us. I think I need to say this officially also in the recording so that I can show my wife. She is a graphic designer and she did the very colorful images that it's very multimodal and it's making everything very like a non-traditional research type of slides, as you might have seen. So thank you, Helen. We did an overview of team dynamics and we looked at the Envision data set. That was a presentation by the origin of the data set. So Dr. Edelman is data, 4 terabytes of videos. And then we went for several coffee breaks and then we did some overview of multi-modal signal processing and applications. That was by James. And then went into video motion tracking. Then we went into multimodal data analysis. I know that it was quite fast for what you're kind of used to, but we announced again and again that this will be recorded and you can watch again. Maybe we also develop an AI that helps you, also that interprets the text or tells you where to particularly pay attention to based on your personality. So, but that happened, and then we went into deep learning. I think it fit really, really well. We did not imagine it to exactly fit like that because we'd not yet had the talks. But I hope you got a sense that we wanted you to take some hands-on knowledge away, foundational things to start your multimodal analysis journey officially. But you know that these tools are lifelong and you have continuous access to the repo. But also, I like that Gerard's session closed with more of, okay, there's still a lot to figure out, but these are the inspirations. This is what machines can do state of the art. This is how it can augment us in our research. And that for me was a very, very good blend. We did not get too many comments online. I hope that tomorrow people can come back fresh and engage better. We would also be looking at the Miro board. Please put up your 3 challenges so that we can integrate them into the sessions. Tomorrow is, again, that intense. We have open phase after a quick recap of what happened today. Maybe I cut that recap short tomorrow. So open phase, then we have kinematic features, a coffee break, then we go into gesture networks. And then we have a module on multivariate analysis, and then we go into semantic network analysis. Frazetti Coladon, Andrea, and Ludovica will be joining us from Italy, so they should have arrived tonight for that session. So, and then we end with a wrap-up. I would leave it for there today. Thank you very much for your full engagement, and we look forward to day 2 of the Envision Bootcamp. Have a safe evening. Cheers.